And the next command that I want to talk about is TweenCurve. Let me search for TweenCurves. The TweenCurves command creates curves between two open or closed input curves. But how? For example, here as you can see, we got two curves, like these two. I rotate one of them, and then I move it, and then I make it non-planar by moving the control points, so it would be more interesting. Then here by using TweenCurve, we can create curves between these two input curves at the specified number. TweenCurves, here we should select the start and end curves. For example, the start and then the end. Check it out. Here we got one curve between these two because the number have been specified as 1, but I specified 20. Check it out. Here we got 20 curves between these two curves. As you can see, we got 20 curves between the two open input curves. Then let us talk about the other points. When we start the command of TweenCurve, while specifying the curves, the endpoint that you click on does matter. For example, if I click on this end, and then for the top one, I click on the other end, as you can see, the directions are not aligned. How can we change it? By flip. Check this out. You can use flip to flip the direction. Here we can specify the numbers like 10, flip, and the output layer for the results, and then the method. But let's talk about match method. Match method specifies the method for refining the output curves, and when we set it to none, it uses the control points of the curves for matching. So the first control point of the first curve is matched to the first control points of the second curve. So it preserves the number of the control points. And then the next one, which is refeed, it refeeds the output curves like using the feedCurve command. Both the input curve and output curve will have the same structure, and the resulting curves are usually more complex than input unless input curves are compatible. And as you can see, it increases the number of the control points, so it automatically recognizes the proper number of control points and then assign them for the curves. And then the last option, which is sample points, then we can specify the number of the sample points to use them in the curves. For example, 10. So the three match methods were none, refeed, and that none does not changes the control points. It uses the control points of the curves for matching for the input curves, and as much control points we got in the input curves, they will be assigned for the outputs. But refeed would increase the number of the control points for the outputs totally automatically, and in sample point it enables you to specify the number of the control points. Well done. In the continuation, let me give you an example so that you can understand the applications of these. For instance, I want to draw an arc. Check this out. For example, at the front view, and then I pick the arc, check it out from the origin point like this way. Following that, in the perspective view, I draw this arc and then I move it, check it out. Then I rotate it like this way. Well done. Following that, I move it upwards. Then I want to connect these two curves. So let me move it more. So let us consider the different cases. TweenCurve, then I specify the curves. Check this out. Right now the default value for match method is refeed, because if we set it to none, then this will be the result. Check this out. Because if it uses the control points of the curves for matching, then the result won't be satisfying. But if we set it to refeed, as you can see, the control points are increased, but we got a reasonable result, and the number of the control points are acceptable because the result is satisfying. Let us try with sample points. For example, check this out. Sample point. It does work out actually, but there is a limit value for specifying the sample number, like 2. Check this out. As you can see, it is not satisfying. So in some occasions, none is not a good choice. And always I recommend you use repeat, because comparing to others, it would be a better choice. And it's interesting to know that you can use TweenCurves even for the closed curves. Suppose that here we got a rectangle like this, and another rectangle inside the first one. By this way, I move it upwards, and then I want to use TweenCurves. Then I select them, check this out. This is the result. And for the number of the curves, 20 for example. Well done. And the point about the closed curve is that while you're working or dealing with the closed curves, the position of the seam point does matter. Just like loft. While we were working with the open curves, we clicked on aligned endpoints. For example, here we got two open curves, the two endpoints that are aligned, and if we flip them, but here in the closed curves, here as you can see, we specify the direction by the position of the seam point, just like loft, and as you can see. So by this way, by adjusting the seam points, you can match them. But when we use loft for creating the surfaces, we were capable to adjusting the seam points, and then we will have such a result. For example, look. But are we capable to adjust the seam points in TweenCurves ourselves? To adjust the seam points ourselves? It seems not. Check this out. We can only flip them, not changing the position. So how can we modify the seam points in closed curves? As I remember, it had its specific command, which was curve seam. Look, curve seam, curve seam. Then I start the command, I select the rectangle. Following that, we can drag the seam point to adjust. Check it out. We can click and drag it. And after positioning it, press enter. So that in TweenCurves command, as you can see, since we have modified the seam point, the result is changed. And this is all because of the adjustment of the seam points. Another example here. For instance, here we got this rectangle, and then I want to draw an oval, or an ellipse actually, like this way. Following that, I rotate the ellipse like this way. I move it upwards like this. Then TweenCurves. First of all, let us check out the seam points. Great, the seam point is well adjusted, as you can see. But we should flip it. Check this out. Exactly. Right? Right now is correct. But if I want to readjust the seam point to revolve the curves, I should start curve seam. Then I select the ellipse. Following that, I drag the seam point to adjust the new position. Press enter. Well done. Again, TweenCurves. Then if you just wanted to observe the preview, you can just flip it. If you click on flip, then the preview will be shown, so that if it was any problem, you can fix it. And after revising it, press enter. So the trick for displaying the preview in TweenCurves is to deal with the option in the command line, like modifying the numbers, flipping the direction. After making changes, then the object will be updated so that the preview will be displayed. So right now we learned how to adjust the seam point in closed curves, and also how to show the preview in TweenCurves before saving the changes. But here, if an command of curve seam, let me start the command at first. Here, if I select these two curves at the same time and then start curve seam, and then I set it to automatic, then it chooses the two closest seam points which are aligned, and then adjust them as the two seam points automatically. It could be helpful since it adjusted the seam points quickly by just setting the adjustments to automatic. because it will be given the right result. Otherwise, you can modify them manually, like this way. Check it out. By this way. Check this out. But if I set it to automatic, it chooses or it adjusts two closest points and aligned for the seam points. If you set it to natural, it specifies the natural seam points for the curves. And here there is an interesting point that I want to tell you. Maybe you imagine that when we want to use TweenCurves among two curves, the two curves should not be aligned. They should be at different heights. But this is not correct. Let me show you something different. Suppose that here we got a square or a rectangle. Then at this top view and this construction plane, here we got a circle like this. Check this out. Can we use TweenCurves between these two objects? And what do you expect? Look. This is fun. Again, let us try. Here, as you can see, there's somehow like morph rule. I minimize the numbers. Check this out, 10 or 5. As you can see, they are inclined to each other, to convert to each other. But this time here, if I modify or readjust the seam points, curve seam, check this out, like this way. Then TweenCurves. Check this out. As you can see, they are not rotated. They are straight. And the rectangle is converting to a circle. Again, curve seam. I select them and then I readjust the seam points. I modify the circle this time. And then I save the changes. I want you to check out the results of the TweenCurves. For example, 6. Check it out. And if I flip them, they are being rotated. So the position of the seam point does matter. Even if the two close curves are at the same construction plane, the seam point controls the way these two objects matched with each other. If you wanted to match them straightly, curve seam, then you should adjust the seam points aligned, for example, both at the right side of the objects. And then we use TweenCurves. Look, I should have flipped it. Let us try again. Flip. I flip the direction. Check it out. Like this way. So the position of the seam point is very important. Another example. For instance, here if I draw a star like this, check this out. And then I want to draw another star that I want to inscribe the sides like this way. Then TweenCurves. Check it out. The seam points are okay. 5 as the number, or 4. Look, they are matched. And this time if I specify 10 and so on, and if I flip them, check it out, like this way. This time if I readjust the seam points by using seam, like this way. Let us check out the results after TweenCurves. 6 for the numbers. They are rotated. Flip. It is not interesting because these seam points are not well adjusted. So we can use TweenCurves if we want to convert one of the objects to the another object. But don't forget to adjust the seam points properly. And another application is that we can use it instead of array. Suppose that here we got a curve like this, and then I hold down Alt and then I click on it. Following that, I move it at the length of 20 units. Then at the other one I click, then I move it 3 units upwards. Let me move it more, 2 units more. Then in the continuation, I want to create 15 curves between these two curves, just like array. But if I want to use array curve, I should add another curve. While we can use TweenCurve, I select these two curves, check it out, and they are not converting to each other since they are totally similar to each other. But I used it because I just wanted to array the curve. Log 12. As you can see, like this way you can arrange them, and then you can convert them to stairs. Check it out. Extrude. Then I specify the direction. I set the base point. Watch this. Here is the result. I select all of them. Again, direction, seam point, and direction. Let me adjust the direction again. I hold down Shift to restrict the direction. Let me set the base point like this way. Great, you see. You can use them simply in creating stairs as I showed you, instead of array. So guys, it's time to practice all of the example. See you.